Hello guys and welcome back to the channel. Today we're going to be talking about how to generate the SIC code for a source program. We are going to generate object code. First, let's look at what the source program that we have been given. Here, the source statement starts like this. Label opcode and operand. We have the opcodes as start, clear, LDA, LDB, base, add, TIX, JLT, STA, RSUB, RESW, end, and etc. And we have operands 3000 x 0 total hash total table comma x count loop total 1 2001 first and etc. Now our main goal here is to generate the object code for the following SICXC program and also to write the object program that is in header record, text record, and end record format. Now we have the mnemonics for the opcodes that we have previously seen over here. These are the opcodes, and for this we have their hexadecimal values. For add, it will be 18. For JLT, it is 38. For LDA, it is 00. LDB will be 68. LDX is 04. R sub is 4C. STA is 0C. TIX is 2C. J sub is 48. J is 3C. LDT is 74. Clear is 84. Now, here, first to generate the object code, we need something called as location counter. The location counter values goes like this. Now there are four formats in SICXC, which would be from format 1 till format 4. Now format 1 would take up 1 byte, format 2 is 2 bytes, format 3 is 3 bytes, and format 4 is 4 bytes. Now the starting address of the start is some start will be 3000. So we have to ignore start, and then we have to look at the next instruction, which would be first clear. Now clear x, it's been given as clear comma x. Here we only have a register that is called x, so it is in the second format, which would take up 2 bytes. 3000 plus 2 would be 3002. So now the location counter value of clear will be given here or here in 3002. Now next, moving on from that, LDA comma hash 0, which is from 3002. This is in third format because there are no register, and it is in third format, that is 3002 plus 3, which would become 3005. Now we write down 3005 over here. Moving on, there is plus LDB. Whenever there is a plus, we know that it is automatically in fourth format. So from 3005 we got plus 4 bytes because it's in fourth format. We get 3009. But the thing is, we don't have to write location counter value for base, which means it will be skipped and moved to the next one, which is add. We go to 3009. We write 3009 in the place of add. Next, 3009 add table comma x. We know that this is in third format, so 3009 plus 3, as it is in third format, we have to add 3 bytes, which will become 3000C. Because 3000, after 3009 in hexadecimal, we don't move on to 3010. It will become 3000A, 3000B, and 3000C. So we got 3000C here, and we will write that for TIX 3000C. And TIX count is also in third format. Because it is in third format, we add 3 more bytes to 3000C, which would make it 3000F. So the location count value after being incremented at TIX count would be 3000F. Now JLT loop is also in third format, which we have to increment by 3 again. So from 3000F, we have to be careful here. After 3009, we have 3000C. After 3000C, 3 increment, we have 3000F. After 3000F, we will go to 3010, and then 3011, 3012. We have incremented 3 bytes, which made it from 3000F to 3012. From here, we have ST8 total, which is also in third format, which means we have to increment it by 3 bytes. So from 3012 to 3015, R sub is also in third format. That is why we have incremented it by 3 more bytes. It became 3018. Next, count RESW. Here RESW stands for reserve word. So reserve word, it has reserved one word. So we usually know that one word takes up 3 bytes. One word consists of 3 bytes. So we have to increment it by 3 bytes. Here we have 301B. 301B. Because after incrementing from 3018, we have 3019, 301A, 301B. So we have incremented by 3 bytes, we get 301B. And then next table reserve word 2000. Now look at this. We are reserving 2000 words, which means 2000 words when each word takes up 3 bytes, which means 2000 words takes up 6000 bytes. When we convert 6000 bytes into hexadecimal, we get 1700. Yeah, 2000, 6000 bytes in hexa. In decimal, we convert it to hexadecimal, we get 1700 bytes. We add that to here, we get from 1000, no, 1770. From 301B, we increment it by 1770 bytes. We get 478B, 4078B. We get 478B, and then here we again reserve one word, which is three more bytes. We increment it 3 more bytes. After B, we get C, D, and E. So 478E. This is the end, and here we have the location counter values in total. Now, moving on to the next one. Here, here we see how to calculate the object code. First, here we have start. We ignore the start. Starting from here, the location counter value 3000. First, clear comma x. Here, clear, as we have seen over here, the hexadecimal value of the opcode of clear is 84 in hexa. So when we convert 84 into decimal, in binary, we get this value 10110100. So here in this, for opcode, we take it is in second, as it is in second format, we have to take all 8 bits. The second format is opcode takes 8 bit, and there are 2 registers, so each register takes 1. So now register 1, register X takes 1, while register X is 1, so register 1 we get 0001. And register, as for is there another register? No, we don't have another register next to X, so it would become register 2 becomes 0. So this R1 is X, that equals 1, R2 is 0, so it becomes 0. Now as you see object code, we just convert this into the object code, which would become 01011 0100 0001 and 0000. Now if we convert this into hexa, here we have 1011, which is 1 plus 2 3, 3 plus 8. 3 plus 8 would become, after 8 we get 9, A and B. So this is B, and here we have 1's place is 0, 2's place is also 0, 4's place is 1, which that is why we've got 4 here. So B4, and here we have 1, and this is 0. B410 is the object code for the first one. Next would be to calculate the object code of LDA #0. Here we have written B410 as the object code of the first clear X. For LDA, the opcode is 0, so 0 we have to write in this format. But the opcode for 0, we have to take, okay, we've written 8 bits, in this, but we have to take the most significant 6 bits out of this for the opcode. And as for NIXBP, we have 6 flags. For this, N is, okay, we're starting here with opcode of LDA being 00, which means we have to convert it to 8 bits, which would be 00000000. Here we take the most significant 6 bits of these 8 bits, as opcode is 6 bits, and NIXBP each has 1 bit per flag, and then we have 12 for displacement, 12 bits for displacement. Now here opcode, as opcode we have to take 6 bits. We take six most significant bits in this, and NIXBP standing for N is indirect addressing mode, I is immediate addressing mode, X is indexed, while B is base, and P is program counter relative. E would be 1 if it is in fourth format. Now, moving on, N would be 0, I would be 1 as it is indexed because we have hash here, and X, I would be immediate because we have hash here, and then X, which stands for index, would be 0. It is not in base relative addressing mode, not, and also not in program counter. So it would be NIXBP would be N0, I1, X0, B1, P0, B0, P0, E0, and the displacement would be 000000000000. And when we convert that into object code, we get first 4 bits from here 0000, and next 4 bits from here 0001, which would be these 4, and then we have 4 zeros here, 4 zeros, 4 zeros, 4 zeros. We get 010000. Moving on to the next one, plus LDB hash total. Now here we have plus LDB hash total. For that, to calculate the object code for that, we have plus LDB, which means it is already in fourth format. So here E becomes 1. So opcode of LDB is 68. Oh, it has not been changed over here, but the opcode of LDB is 68, which would be 01101000. We take 6 most significant bits from here, which would be 011010. So after that, we have NIXBP, and this E would be 1 because it is in fourth format, and then I is also 1 as we have hash total. So immediate addressing mode, hash means immediate addressing mode, so I will become 1 automatically. Now if you can see this, it would become 0478B. That would be the object. 0478B would be the address. So we have to get 20-bit address, and here we have 6 most significant bits of this, which means first 4 would be 4 plus 2 is 6, and then we have 9, and then 10478B. Here we have 1 is from IXBP, so here next 4 significant bits we get that. So in total we have 6910478B. Moving on to the next, base is an assembly directive. We don't calculate the object code for this. Moving on, we have for the next one, add table comma X. So here we're going with third format again. Now here N is 1, I is 1, X is 1, B, P, E, P is 1, and E is 0. Here looking at this, address is 18 and X equals 1, which would become 0001. Displacement would be 301B minus 3003, which would give us F as answer. F is 1111. So PC relative, it is in the range of minus 2048 to plus 2047. The object code would be 1BA00F. as we have calculated this many so far, I won't bore you with the deeper details as to as how to calculate the other ones. I'll just show you how it is done, so you can do it by yourself. You can try to do it. If you can't get it, watch the video again, and then try to understand how it works. Here we have for TIX count. Now this is also in third format. We go with 12-bit display again, and here we get the opcode of TIX is 2C, which is 00101100. So we take six more significant bits. Here we have it, and then displacement we have 9, and 9 in hexa will get 1001. As to program counter relative, yes, it is in the range of -2048 to +2047, which is why P would become 1. So object code would be 2F2009. The next we're moving on to JLT. So in JLT we have the JLT opcode is 38, which is 38. In binary it would be 00111000. So now the object code for this would be 3B2FF7. Moving on to the next one. The object code for this one is 0F4000. Here the opcode is for STA it is 0C, which would for which we have to take the first six most significant bits, which means it would become 1248, which means it would be this would be the opcode, and then the displacement we calculate by the applying this formula, as we all know, 478B minus 3015, which would become 1776. It is in the range of -2048 to +2047, which is why it is program counter relative. If it was not within the range, it would have gone to a base relative, which is 024095. Now the object code is 0F4000. The next one we have is R sub. For R sub, the opcode is 4C, which of which we have to take the first six most significant bits, which is 010011. It is the opcode, and then for the as for the object code, we have 4F0000. Moving on to the next one. For RESW, we don't calculate the object code. For end is assembly directive, we don't calculate the object code, but we can write the starting address as it is given first. So we starting address would be 3000. So this is where we end the object code calculation. Now we have to convert it into the header record, text record, and end record format. As we can see here, for header record, the first column would be H, and then after the cap symbol we write sum, which is the first operation here, which is next to the start, which is the name of the program. That would take from 2 to 7 columns, which is 1, 2, like first one is gone already, so 2, 3, 4, 5, 6, 7. So we have the object program name here as sum, and then after that the cap symbol, which means we are moving on to the next one, which is 8 to 13 columns would be starting address, which is 3000. But for 3000, here it is given as 6-bit, so we have to take 2 zeros next to 3000, so it is 003000. And then next in the end we have 14 to 19 columns for the length of the object program in bytes, which means it is also in hexa. 178E is the length of the header record. Next, moving on to the text record, column 1 would be T, cap symbol. Next, from column 2 till 7 is a starting address in this record, which would be again 003000 cap, and then next would be columns through 8 to 9 would be the length of the object code in this record in bytes, which would be 18, and then we have column 10 till 69 object codes. So here we write the object codes of the things we have here, B410, 0100, 0000, and 691047 8B. All those things we have written here. Starting from column number 10 through 69, we get all the object codes here. As for the end record, column 1 would be E, column 2 till 7 will be address of the first executable instruction in hexa, which is first executable instruction address is 3000. So this first is 3000.